Hello, today we are going to start a next topic in electrochemistry, and the topic name is effect of dilution. Okay, so effect on dilution we are going to see on conductance, that is G. Then we are going to see on conductivity, that is K. Then we are going to see on molar conductivity, that is lambda m. Then equivalent conductivity, lambda EQ. Okay, so we are going to study about the effect of dilution. Now dilution means what? We have to dilute. Now dilution means, dilution can be done in two ways, either by increasing the volume, yes or no, or by increasing the moles. Clear? So we can dilute in both the method, either by increasing the volume or by decreasing the moles. So there are two methods of doing the dilution, either by increasing the volume or by decreasing the number of moles here. Clear? But to remember or to mug up, remember that in the effect of dilution, except conductivity K, everything increases. If in exam they ask anything to you, in the question they ask you effect of dilution, except conductivity, everything increases. Conductance also increases, molar conductivity also increases, and lambda EQ also increases. Only conductivity decreases. Clear? So this I told you to only to remember, so that if any question is coming, any MCQ is coming, so that you can directly give the answer, that in effect of dilution, except conductivity, conductance, molar conductivity, equivalent conductivity increases, only conductivity decreases. Please remember this. So now we are going to discuss one by one why they increase or why they decrease. So we will see first conductance. See, before going to the conductance, as you know, I will discuss two words, that is strong electrolyte and weak electrolyte. So strong electrolyte is an electrolyte which get dilute, completely dissociate on dilution. Please remember this. A strong electrolyte is one which get complete dilution, or there is a complete dissociation on dilution. They will dissociate completely on dilution. For example, I have KCl. 2 moles of KCl if I have, or say I have a 20 moles of KCl, and if I say this is a strong electrolyte, then according to definition of strong electrolyte, that strong electrolyte is a electrolyte which get complete dissociate on dilution. So when I add water, say I add 20 ml water to this KCl, so I will get 20 K plus and I will get 20 Cl minus, once for all, at once only they will get dilute. Now if I add 40 ml, the ions remain same, it will be 20 K plus and 20 Cl minus only. If I add 400 ml also, it will be 20 K plus and 20 Cl minus. So this is nothing but a what? Strong electrolyte. A strong electrolyte is an electrolyte which get completely dissociate once for all on dilution. Whereas weak electrolyte. So what can be the weak electrolyte? A weak electrolyte is an electrolyte which get incomplete dissociate, where the dissociation is on 100%. Incomplete dissociation will be there on dilution. For example, if I take an example of weak electrolyte as CH3COOH. If I take 20 CH3COOH, when I add 20 ml of water, they will dissociate 5. So I will get 5 CH3COO minus and 5 H plus. So 15 will be remaining as CH3COOH only. Okay, again when I add again 20 ml, so when I add extra 20 ml means I will get now 40 ml. So in 40 ml from this 15 CH3, only 5 again they will get dissociate and 10 will be remaining as it is. Again if I add again 50 ml and I make this 40 ml to 100 ml, then also from 10 only 6 CH3COO minus get dissociate and 4CH3COOH remains as it is. So as and when I go on dilution, the number of ions goes on increasing. Means here the dissociation is not complete up to the last stage. Up to the last stage you will see the molecule also and you will see the ions also. So such a type of electrolyte is known as a what? Weak electrolyte. Clear this part? See, I know this is a very bit confusion topic. See, what do you mean by strong electrolyte means? A strong electrolyte get complete dissociate. You add how much amount of water? They will get once for all, they will get complete dissociate, and that number of ions remains as it is on diluting how much you want. But whereas weak electrolyte is an electrolyte which go on dissociating number of ions. They will never get complete dissociate. As you go on adding the number of, as you go on adding the water or as you go on dilution, the number of ions get released as per the dilution. Okay, so in strong electrolyte there is a complete dissociation of ion at one point, once for all the dissociation is done. But whereas in weak electrolyte, once for all dissociation is not done. So such a type of a dissociation we say as a incomplete dissociation. Clear this part? So now I will start conductance. Now see here, in conductance first we have to see, for example, if I take one beaker here, in that beaker I am filling some electrolyte. Say electrolyte is KCl. Now it is just, so I will discuss for here strong and then I will discuss there. First I will discuss for strong electrolyte. Clear? So for example I am taking one beaker, in that beaker I am taking KCl. As and when I put the KCl, they will get dissociated into K plus and Cl minus. They will get dissociated into what? K plus and Cl minus. Now you know in strong electrolyte there is a complete dissociation. Yes or no? There is a complete dissociation. Clear? When I take any electrolyte or when I on dilution, so as and when I add the water, see here, first I was having KCl, it was having K plus and Cl minus. As and when I dilute, what happens? The distance between K plus and Cl minus increases. So what happened on dilution? The distance between, see what I have done, I have taken KCl and I have put in the water. When I put in the water, they get dissociate K plus and Cl minus in this much amount of water. So they get complete dissociation. Now what I am doing, I am adding water, means I am doing what? Dilution. When I dilute, what happened? The distance between these ions, that is this K plus and Cl minus, the distance between these ions increases. So on dilution, distance between ions increases. Yes or no? Because why the distance between the ions increases? Because I am going on dilution, because I am adding water. So as and when I add the water, first the KCl are here. When I add the water, the distance between KCl increases, again increases, again increases. So distance between their ions of the electrolyte goes on increases. So distance between the ions increases. As the distance between the ions increases, the ions are free to move. Ions will be feeling free to move. So they can freely move because the distance between the ions is increases. Now there is no attraction between them. So attraction is slowly getting broken. When attraction is broken, the ions are splitting from each other. And when ions are splitting from each other, they are free to move. And when they are free to move, means the conductance means what? Conductance also say that's only. Conductance means the conductance is a property of movement of ions. Means when ions are free to move, means movement increases. Movement increases means what? Conductance increases. Conductance increases. So what happens as I on dilution, see I am taking a strong electrolyte. So when I take a strong electrolyte, there is a complete dissociation. Means if I have taken 5 KCl, so I will be having 5 K plus and 5 Cl minus. Suppose on once for all they have separated 5. For example, I am taking 5 KCl. So on dilution, what happen? I will get 5 K plus and 5 Cl minus. So in this reaction now there are 5 K plus and 5 Cl minus, but they are near to each other. So there will be attraction. So movement will be not so much. Movement will be less. Now what I am doing? I am adding water, means I am diluting. As and when I dilute, the distance between this 5 K plus and 5 Cl minus increases. So on dilution, the distance between the ions increases. Now how many ions I have? I have 5 K plus and 5 Cl minus. So this distance increases. When the distance increases, the attraction decreases. When the distance increases, the attraction decreases. Now the attraction decreases means ions will feel free to move. So ions can move freely. Means their mobility also increases. What increases? Mobility increases. And mobility increases, that's what nothing but what? Conductance. So conductance G increases. So you have to remember here that conductance for a strong electrolyte on dilution increases. Clear? So here conductance increases. And what is the main reason? Here the conductance increases only due to what? Ions. So here remember this point, that conductance increases due to ions only. So if any question is coming in exam, that conductance for strong electrolyte increases only due to ions. Yes or no? Because I am taking a strong electrolyte, they will get completely dissociated. As they get completely dissociated, so the distance between the ions is less. But as and when I do the dilution, the distance between the ions increases, attraction decreases, hence attraction decreases, so they are freely to move. And freely to move means their mobility of ions increases. That's what nothing but conductance. Conductance means what? The property of movement of ion. Clear? The property of movement of ions, that is nothing but a what? Conductance. So the conductance increases. Now in strong electrolyte, conductance increases due to what? Ions. So please remember this now. Clear? So here conductance increases. Now we will discuss about here weak electrolyte. Now see here. I hope you are understanding. Clear? Suppose instead of KCl, suppose I am taking 100 ml solution and here I am putting CH3COOH. Okay, say I am putting 10 parts of CH3COOH. Okay, so as and when I put the CH3COOH, and you know this is a weak electrolyte, yes or no? So CH3COOH is a which? Weak electrolyte. So as and when I put the 10 CH3COOH, out of 10 CH3COOH, only 2 CH3COOH get dissociate. So 8 remains as it is, yes or no? So I will get 2 CH3COO minus and 2H plus I get here. Suppose, because as we know CH3COOH is a weak electrolyte, and you know weak electrolyte does not completely get dissociate. So what I have done, I have taken the weak electrolyte. Yes or no? I have taken weak electrolyte. Clear? Now when I have taken the weak electrolyte, so you know in weak electrolyte I will have incomplete dissociation. Yes or no? I will have what? Incomplete dissociation. So on dilution, what happened? So on dilution I will get ions also. See here, I have taken 10 CH3COOH. Out of 10 CH3COOH, how much get dissociated? Say example 2 get dissociated. So what is remaining? So 8 CH3COOH remains as it is. Yes or no? Yes or no? So for example, I am taking this is 100 ml as water. I told you, no? I am taking 100 ml as water, and in this 100 ml I am putting 10 parts of CH3COOH. When I put 10 parts of CH3COOH, so what happened? As it is a weak electrolyte, so dissociation is incomplete. Okay. Now, as dissociation is incomplete, so out of 10 CH3COOH, only 2 CH3COOH get what? Dissociate. That is 2 CH3COO minus and 2H plus. So I have 2 ions here, and 8 remaining as it is. So what happens on incomplete dissociation? So due to incomplete dissociation, when I do the dilution, on dilution I will get 2 kind of product in the solution. One I will get ions, and another I will get the molecule also. Yes or no? See, now in the solution what I have? So out of 10 CH3COOH, so in the solution here, see here, in the solution I will be having 2 CH3COO minus, then I will have 2H plus, and then one thing more I have 8 CH3COOH also. Yes or no? So on dilution what happened? As I added water, so as you know it is incomplete dissociation, so I will get ions also and I will get molecule also. Now suppose instead of 100 ml, now I am doing the dilution. So when I do the dilution, say I am taking 200 ml. So when I do the dilution, what happens? Again, what happens? Out of this 8 CH3COOH, more 2 get dissociate. So when 2 get more dissociate, so here I will get 4 CH3COO minus plus 4 H plus, and I will get plus 6 CH3COOH at what? At 200 ml. So how much dilution I do? How much dilution I do? In the solution, 2 kind of product remains. One is ions and another one is a molecule. Yes or no? So as on dilution, I get ions also and I get molecule also. So on dilution, again the distance between the ions also increases. The ions which are formed, the distance between them also increases, and number of ions also increases, and number of ions increases, distance between the ions also increases. So dilution, on dilution, what I will there? The mobility also increases. So what happens here? Mobility increases. Mobility of what? So here mobility of ions also increases, and here mobility of molecule also increases. And mobility increases means what? Conductance increases. Clear? So whether it is a weak electrolyte or whether it is a strong electrolyte, conductance increases. In weak electrolyte, what happens? On incomplete dilution or incomplete dissociation, on dilution I will get 2 kind of product. I will get ions also, I will get molecule which is undissociated molecule. Again on dilution, the 2 product only I will get ions and I will get molecule. But on dilution, the distance between the ions goes on increases. So distance between the ions goes on increasing, and there is a molecule also. So the mobility of the ions also increases and mobility of molecule also increases. Mobility increases means movement increases, and movement increases means conductance increases. So you remember this, that conductance increases on dilution for strong electrolyte also and for weak electrolyte also. For strong electrolyte, the conductance increases due to their ions, but for the weak electrolyte, conductance increases due to their ions as well as free molecule or undissociated molecule. Do you clear this part? So your conductance increases. Clear? I hope you have understood. So now I will write down here. So I will write down here, conductance increases for strong electrolyte. The reason is only ions. So conductance increases for strong electrolyte due to ions, and for weak electrolyte due to ions as well as undissociated molecule. Please remember this. This can come in the exam. Clear this part? So conductance increases on dilution. So special case for strong electrolyte due to ions, because ions once get dissociate on dilution, the distance between the ions increases, distance between the ions increases, mobility increases, conductance increases. Because of weak electrolyte, as you know, it is an incomplete dissociation. So when I add the water or when I do the dilution, I will get the ions also and I will get the undissociated molecule also. So on dilution, what happened? I get more and more ions, and I also get the undissociated molecule. So distance between the ions also increases in weak electrolyte on dilution, and there is also undissociated molecule. So there also mobility increases. Now their mobility increases due to ions and due to undissociated molecule. So the conductance increases. So in a strong electrolyte, conductance increases due to ions, whereas in weak electrolyte, conductance increases due to ions as well as the undissociated molecule. So in short, conductance increases on dilution. Clear this part? Now see, next point we will see conductivity. Say kappa. Clear? Now if you see the conductivity, okay, so you know conductivity K means ions per unit volume. So conductivity K, it depends on what? So it depends on ions per ml. Yes or no? You have seen, no? Conductivity K is equal to G For what? For 1 ml? Yes or no? So it depends on ions per ml. Suppose if I take one beaker, okay, in that beaker I am putting one electrolyte, say AB. I am putting one electrolyte what? AB. As and when it goes inside the electrolyte, it will form A plus, and here it will form B minus. So it will form A plus and B minus. So as and when if I put the electrolyte in the water, they will get dissociate A plus and B minus. Now suppose if I say if I take 1 ml water, so in 1 ml water how much ions I have? I am talking about ions. So one I have positive ion, one I have negative ion. Means total ions, how many I have? I have 2 ions. Yes or no? I have 2 ions. Now on dilution, if I do on dilution, dilution means what? Adding of water. So if I make this 2 ml, so what will be the ions? Ions remains as it is, it will be 2 ion only. If I take 3 ml, so if I do the dilution, if I make from 2 ml to 3 ml, again what happens? Ions remains as it is, 3 ion, sorry 2 ion only. If I take 4 ml, how much ions I have? I have 2 ion only. If I do n ml, again how much ion I have? I have 2 ion only. So now what happens? Understanding or not? See, first AB have dissociated. See, I am taking one part of AB. As and when if I put in one AB, so I get one cation, one anion. Yes or no? Or if I say, suppose if I am taking 5 AB, so I will get here 5A plus 5B minus. So how much ions I have? I have 10 ions. So suppose if I say in 1 ml 10 ions, how many ions I have? Total ions 10. So in 1 ml 10 ions. If I do 2 ml, the ions remain same. How many ions? 10 ions only. How many ions here? Also 10 ion. 4 ml also 10 ion. N ml also 10 ion. Now we have to see conductivity means what? Per ml. Now you know when 2 at 1 ml, ions are how many? 10. So here ratio is 10 by 1. Yes or no? So here answer I will get 10. Here 2 ml 10 ions. So in 1 ml how much? 10 by 2. So how many? 5. Again here 10 by 3. Yes or no? In 3 ml 10 ions. So 1 ml how much? So in 1 ml 10 by 3. Yes or no? Because per ml you have to see, no? See 1 ml 10 ions. So 10 by 1. Now in 2 ml 10 ion. Because ions remain same. So when I'm doing dilution, means I'm adding the water, so I have increased the volume. So from 1 ml I have done the 2 ml. So when 2 ml 10 ion, so in 1 ml how many ion? So 1 means 1 tens are 10 by 2. So 10 by 2 means how many? 5. When 3 ml 10 ion, so again here 1 ml how many? So 10 by 3, say 3 point something 33. Again 4 ml 10 ion, so again 1 ml how much? So 10 by 4. Yes or no? So you can see here slowly as I go down, as I go on increasing the water, the per ml value decreases. Yes or no? On dilution, what I observed here, on dilution, per ml value is decreasing. Yes or no? So on dilution, per ml ion decreases. Yes or no? See here 1 ml 10. So 1 ml means 10 ions. Now 2 ml 10 ions. So 1 ml how much? 10 by 2, 5 ion. 3 ml 10 ions. So 1 ml how much? 10 by 3. So as and when I go on dilution, so when I increase the volume per ml ion decreases. So on dilution means increasing the volume per ml ion decreases. Per ml means what? Per ml is nothing but what? K. Therefore K what happens? K also decreases. So here K decreases. Clear this part? See, what do you mean by K? K is completely depend upon the number of ions per ml, per centimeter cube per ml. On dilution what happens? See, I was having 1 ml 10 ion. So 10 by 1, 10 ions will be there. Now when I have 2 ml 10 ion, in 2 ml, because I am doing dilution, I am adding water. So from 1 ml I am making how many ml? 2 ml. So when in 2 ml I have 10 ion, so again in 1 ml how much will be there? So 1 tens are 10 by 2, 5. Again 3 ml 10. So in 1 ml how much? 10 by 3, then 10 by 4, then 10 by 5, then 10 by 6, then 10 by n. If I calculate the value, if I see here, as I go downside, the value go on decreasing. See here 10, here 5, here 3.3. This value per ml value is decreasing, whereas volume is increasing. Per ml value decreases, whereas volume increases. So I can say on dilution or increasing the volume, per ml ion decreases, and per ml ion is nothing but a what? Conductivity K. So conductivity K decreases. Conductivity K decreases. Clear this part? So So conductivity K decreases. Clear? Now next. We'll see next molar conductivity. So we know that lambda m equal to k 1000 upon m, or k into 1000 upon m, or 1000 upon m is nothing but what? Volume only, k into v. Yes or no? This 1000 upon m is nothing but what? Volume per ml. We have seen, no, that molarity equal to mole per liter. Mole means 1 mole, so 1 by v liter. V liter equal to 1 by m. Now v ml means 1000 by m. So this is nothing but what? Volume. So can I say that lambda m equal to k into v ml? Now see here, on increasing the dilution means what? I am increasing the volume. Yes or no? I am increasing what? Volume. So as you know, as increasing the volume, k is decreasing. Just now I told you, no, on dilution means increasing the volume, k is decreasing. So what happened to the lambda m? Now you have to understand. Experimentally it is proved that when volume increases, kappa decreases, but not as compared to volume. Means what? Means, see, volume increases, kappa decreases. Yes, I agree. But the decrease is not as compared to the volume. Volume increasing is, the effect of volume is more. When volume is increased 5 times, suppose when volume is increased 5 times, kappa is decreasing 2 times. When volume is increased 10 times, kappa is decreasing 4 times. When volume is increased to 15 times, kappa is decreasing 6 times. So ultimate whose effect will be more? Ultimate volume effect will be more. So here volume is doing what? Volume is increasing. So lambda m also increases. Clear? See here, lambda m equal to k into v. Now on dilution means we are increasing the volume. So we know on dilution k decreases. Yes, I agree. But experimentally it is proved that the effect of volume increasing is much more than the decreasing of kappa. So example, when I increase the volume 5 times, kappa is decreasing 2 times. When I increase the volume 10 times, kappa is decreasing 4 times. When I increase the volume 15 times, kappa is decreasing 6 times. Means ultimate whose effect is more? Ultimate volume effect is more. And volume effect is of increasing or decreasing? Volume effect is of increasing. So volume increases, lambda m also increases. Similarly for lambda EQ. Lambda EQ also what? Increases only. Here same I will say, lambda EQ equal to k 1000 upon n. Now k into 1000 upon n, and this is nothing but a what? 1000 upon n is also nothing but volume in liters or volume. Yes or no? Here also lambda EQ, volume increases, kappa decreases, but the effect of whose is more? Effect of volume is more. And effect of volume is increase or decreasing? Increasing. So lambda EQ also increases. This is experimentally has been proved that the effect of increasing of volume is much more than the effect of decreasing kappa. So whose ultimate effect will play? Ultimate effect will play of volume. So ultimate effect of volume is of increasing. Then the kappa means when volume is increasing 20 times, kappa is decreasing 3 times. So ultimate whose effect is more? Ultimate effect of increasing is more. And who is increasing? Volume. So ultimate this lambda EQ directly depend upon the volume, or lambda m is also directly depend upon the volume. So here in short, ultimate final effect will be of volume. So here volume is increasing. Here also volume is increasing more as compared to kappa k. So lambda m and lambda EQ also increases. So this is something but a what? Effect of dilution. Clear? If you have any doubt, you can ask me directly. Thank you.